Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks who are Geeks problem of the day, and today's problem is number of paths in a matrix with k coins, and it is a medium level problem. So the problem is a very standard problem, and it basically says that you have been given a n cross n matrix and you have been given a some value k. Now we will be starting from the top left cell and we have to go to the bottom right cell. In each move, either we can move down or we can move right. We have to find the total number of ways such that we can make the total sum of coins encountered in that particular path exactly equals to this particular value k. Right. So let me just take this example. They say that there are two paths in this particular case. We'll just discuss this. So we have it here. Now it says that the number of paths in this particular array, double dimensional matrix of size n cross n, such that the total sum is exactly equals to k is 2, and this particular 2 is our answer. Let us see what are those paths. These are 1 2 6 2 1. So 1 is here, then you can go here, then you can go here, then you can go downwards, and then you can go right. If you see the total sum 6 7 8 9 10 11 and 12, right? The total sum is 12, and this is the exact value that we need. Similarly, the second path is 1 2 3 5 1, that is 1, then we go 2, then we go 3, then we go 5, then we go 1, right? In each step we can either move down or we can move right, but if you see, try to form any other path except these two paths, you will never be able to find an answer, right? So this is how the problem is. Now how can we solve this problem? Since the constraints are very small, these are 100 100 and 200 I believe, so we can solve this problem with n cube approach. Let us see what we are going to do. The final approach will look something like this. So this is going to be a DP array of size of, which is a 3-dimensional array, and it has coordinates I, j and sum. So what is this DP of I, j and let's say sum denoting? Right, I is denoting my current row, j is denoting my current column, and sum is denoting the remaining sum. So what is this I, j and sum together denoting? These are denoting what are the number of ways to form exactly sum which is the value that is being given to us starting from I comma j, right? If I and j are my starting coordinates, what are the total number of ways to form exactly this particular value sum, right? So with this particular approach in mind, what is going to be our base case? Let us discuss that. Our base case is going to be obviously when I is equals to n minus 1 and j is equals to n minus 1, right? This is the case when we have reached the bottom right cell and we cannot go any further. So if in this particular case my sum, that is the remaining sum that I want to form, is equals to my array of I n minus 1 or array of I j, my answer is going to be 1, otherwise my answer is going to be 0. So basically what I am saying is, if I have reached this particular cell and my remaining sum that I wanted to form starting from this particular cell is equals to the cell value itself, then it means I have found a valid configuration, or from here there is a valid path, that is this cell itself. And otherwise, if the sum is not same equals to this last value, then my answer is definitely going to be 0, right? So once I know this, I just need to form a general case for all the other cases. So let me just write my helper function. So in this case, obviously we are going to receive three values. So let's say R is denoting the row, C is denoting the column, and sum is denoting the remaining sum left, right? It is going to return an integer or a long in this particular case, right? So now what we have here is, first of all, we are just going to write the base case. So if R is equals to n minus 1 and column is equals to n minus 1 as well. So now in this particular case, we are just going to return dp of R C sum is equals to sum is equals to array of R C, right? So basically, if the remaining, since we cannot go anywhere from this particular row and column, if the remaining sum that we wanted to form is equal to the cell value, then it means we have to return 1 from here. That means this is a valid path, otherwise it is going to be an invalid path. right? Now what we have to do is we are going to move forward with the other general case. Now we also have to make sure that if this state is already computed, that means if RC sum is not equals to -1, then we just have to return dp of RC and sum, right? In all other cases, what are we going to do? We are going to explore the two possible paths. So one is to go down and one is to go right, right? Let's say we are just doing something. We will maintain a dx and dy array. I'll discuss it in a while. What is that? But let's say we get the new coordinates new x and new y, right? So for both down and right, we are going to get these coordinates, right? Now let's say, or let me better call it new row and new column. First of all, we have to check whether this new row and new column is a valid cell or not. If this is a valid cell, then what are we going to do? We are going to set dp of I or dp of RC sum plus is equals to dp of new row, new column and sum minus array of R and C, right? And before that, I'll come to this in a while. Before that, if sum or if array of RC is greater than my given sum or remaining sum, I can just return 0 from here. So let us discuss all of this that I have just written now. We have discussed till here, right? Now the very first thing is, if my current cell value is greater than the remaining sum, then I can definitely not form an answer, and that is why I can return 0 from here. Otherwise, I am going to form this variable nr and nc, which is new row and new column. This new row and new column are basically going to be in the two directions, down and right. We are not discussing how we are getting this right now, but we just know that for one step we are going to get it for the down direction, and for one step we are going to get it for the right direction. Now what I do, if this direction is valid, new r and new column is a valid value, then dp of RC sum, I'll have to add certain number of things to it. What is that thing? That is the new row, new column and sum minus array of RC. So basically, let's say I'm at this particular cell. Let me just draw it. So I'm at this particular cell, right? There will be two cells, one to the right and one to the down, right? Now I want to move to this particular cell, right? Currently my sum is this particular value. When I move to this particular cell, my remaining sum will be something minus this particular value, right? So what I'm going to do, I'm going to do sum minus array of current cell value, array of RC, like this. Similarly, when I go downwards, I am going to do the same thing so that the remaining sum decreases, right? This is how I'm going to find my answer from here. Now, it will be better if I don't write it as dp. Since we are using a helper function, we are going to write it as helper of new row, new column and sum minus array of row column, right? This is how we are going to solve this problem, and at the end we can just return dp of RC and sum, right? This is how you can solve this problem. The only important dp state you need to remember is, what is dp of ij sum denoting? It is denoting the total number of ways to form exactly this particular sum starting from I and j, right? So let me show you the code. Now first of all, I have defined this directions array, that is dr and dc, which is 1 0 and 0 1. So basically, if I add dr of 0 to the row and dc of 0 to the column, it is going to help me move in the downward direction, and otherwise in the if I use the index 1, it is going to help me to move to the right direction. You can clearly see that the row doesn't change and the column increases by 1. This is going to be the right direction, and this is just a cleaner way of going through the different directions. Now I have initialized my dp array, so it is of size n cross k plus 1. K plus 1 primarily because we needed the value k as well, and all of them are initialized with -1, and the values are long, so I took it because the return type is long as well. Now what I have done is, I have a simple helper function, but let us see how we call it. So I am just calling my helper function at 0 0, that is starting from the 0th row and 0th column, which is our starting point. What are the total number of ways if I need this particular sum k, right? This is exactly what the question asked. Now I have a base case inside my helper function, that is if r is equals to n minus 1 and c is equals to n minus 1, I am just going to return dp of rc sum is equals to sum equals to array of RC. That means this expression will be true when sum is exactly equals to the cell value, otherwise this will be false. Now I am just going to return dp of RC sum is not equals to -1, then that means this particular state has been computed, so I return the pre-computed value. Now If dp of RC sum, I just initialize it with 0, and if this current value, that means array of RC is less than equals to sum. So if you see here, I just return directly from here if the value was greater, but instead of returning here, I'm just calculating this particular value only when our array of RC sum is less than equals to sum, right? Now I'm just going to different directions. So I have a dir loop which goes through different directions, and I'm calculating my new row as row plus dr of direction plus new column as column plus dc of direction. Now I just check this direction is valid or not. These new coordinates that I found are valid or not by passing it to the valid function nr and nc, right? So this valid function is very simple. If x is less than 0 or x is greater than equals to n, or y is less than 0 or y is greater than equals to n, I just return 0. That means if this new coordinate x and y are out of bounds for the grid, then I have to return 0, otherwise I return 1. Now dp of RC sum will get added, will have some value get added to it, and that value is helper of nr, nc and sum minus array of RC. So basically what I am saying is the total number of paths starting from RC having the sum this particular value is going to be the total number of paths starting from this new coordinates, and the sum decrease, that means sum minus array of RC. So this sum is with whatever I am decreasing is the current cell value, right? And at the end I can just return my current state value dp of RC in sum. So this would be the final solution. Let me just quickly submit this so that I can show you that this particular code works and the solution is absolutely correct. So you see this passes all the test cases and the solution is correct. I have a lot of wrong attempts as well. Let me just show you. So I was getting TLE in all of these attempts. I'm not sure why this is TLE, because I was writing this exact same code just in iterative format. You can clearly see that this is the exact same logic written in iterative format, but this doesn't work for some reason. So for this particular problem, you'll have to go to this recursive approach only. And that is it for this particular video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.